Operational systems, basically, when we talk about what are operational systems are just what their name implies. So it's like any system which helps enterprise to run their day-to-day operations. That is operational systems. Example, the OLTP systems, online transaction processing systems. Like, take any example, like, take a bank, take a finance company, take an insurance company, take a what do you call a retail mall, or retail mart, like Walmart or some other kind of. So all these, they have their own OLTP systems where they have an interfacing. They have their kiosk which will interface with the customers, wherein every day so many millions of transactions will happen, and the data is being stored in their OLTP systems. So these are the operational systems where people use to run their day-to-day enterprises. So these are the backbone systems of any enterprise. Like, you take any enterprise, they'll have this operation systems. Now, when we talk about operation systems, I'll just try to mention, if you, I don't know, like if you remember, in 1990s and all, ERP was very famous. ERP or OLTP systems. Before that also it was there. But the ERP trend has come in the 1998, 96, 98. ERP, like SAP, PeopleSoft, and BAN. There are quite a few ERPs which are very famous in those 1990s era. The reason is, like, before this, do you know how the IT picture was like before in 1980s and all? Enterprises used to have DBMS in pictures. So they used to have standalone applications. So standalone applications through which they used to do the transactions. So for example, take the example of Walmart. Maybe long back, when they started their operations, say let's say 1980s or somewhere, I'm not sure if it existed those days, but let's take any retail industry, a retail company. In 1980s, the way they worked was like they used to have a standalone system through which all the transactions are done. So all the transactions are done, and they used to store in a DBMS. So those days DBMS used to be something like FoxPro, and there are certain other DBMS where slowly Oracle has come into the picture, wherein people have started using Oracle as their database, and then slowly standalone applications have become very famous. When you say standalone applications, what I mean is these are customized applications based on the requirement. A software company, an IT company used to develop an application and deploy it in the enterprises. So all enterprises used to install these customized standalone applications, and the data, like using front end. Those days it's like, especially if you see, Oracle DTK was very famous. Oracle DTK was being used, wherein using D2K they used to design the front end, and using the front end they used to enter the data, and the data used to stay in the Oracle database. So this was the trend those days in 1980s. Then those days the concept of integrating the data between different applications was not possible. Like those days it's like either it used to be HR system, and maybe if they want a finance system, like that, individual standalone applications were there where the data will be stored. Like HR system used to store the data in Oracle, maybe having a separate schema, and financial stored in Oracle, like that. So everything was standalone, there was no integration, and as such the data transactional systems used to exist then also, but there was no integration. So slowly the trend has gone to 1990, where people have started talking about, in 1996 mostly, people have started talking about ERPs. ERPs wherein they were talking about like SAP, Oracle Financials was very famous, and SAP was famous. Burn was there. So all these things, like these ERPs, they were talking about integrating multiple operational systems. So when you say multiple operational systems, like a company used to have finance, HR, it used to have supply chain. So earlier in the standalone applications, all are standalone. They used to exist individually, but now all these systems, they have started integrating using ERP. So finance used to communicate with the HR system, HR system used to communicate with marketing, maybe like that. They started optimizing their individual applications by integrating these systems using a ERP software. It could be Oracle Financials or SAP or PAN. So this is the era where OLTP systems have come into the picture, where typically operational systems or OLTP systems were in place wherein the transactions were done through the front end and the data is being stored in a back end. And the data which is used to store in back end used to stay there for maybe a year, maybe yearly. Like yearly they used to take backup. Yearly backups were very prominent, and they used to store the backups in tapes, yearly backups in tapes. And then again next year data, again they will start freshly. So that's how things were those days. So operational systems are nothing but these are the systems which are used for the day-to-day enterprise operations. And even today there are all the applications, they interface with their customers using operational systems. Like take any example, go to a bank, you'll find an operational system, OLTP system, wherein the transactions are being done in their operational systems and the data is being stored in their underlying OLTP databases. So what are the OLTP databases? It could be any database. It could be Oracle, or it could be, so OLTP databases could be, so OLTP databases, there are a number of OLTP databases. So OLTP databases, we have got Oracle, I got SAP, SQL Server. So there are a number of databases where the OLTP data used to be stored. So that's how the operation systems work. And when you look at the characteristic features of an operating system, operational systems, these are the few characteristic features, like continuous availability. When you say continuous availability, what I mean is throughout the business hours of your enterprise, 24/7. There might be, you can also say sometimes it will be 24/7 for certain systems, or it could be 365 days into 24/7. So continuous availability. So the enterprise system should be available to the business users or to the operational users continuous. So when we are talking about users over here, users could be your operational users who actually use the system on a day-to-day basis in the business hours. Operational users who use the system in the business hours. And there might be top management which want to use the system whenever they want. That is 24/7. And there might be end users or customers who want to access their data 24/7. So all these are nothing but, what is the example of the first one? It could be your normal ERP system. Let's say take the example of Walmart, and in that you can take the example of let's say operational manager. Operational manager, he wants to use his system on a day-to-day basis in the business hours. So when he comes morning to the office, like he has to see like what is the stock available, like what was the yesterday's sales, all these things. Like there are certain things which he will be looking at his operation systems to understand the position of the stock, to understand the position of the employees' availabilities. So all these things you'll be looking at. And when we talk about the top management should be able to view their businesses like whenever they want. They should have an overall picture of what is happening in the operation in their particular enterprise. So, and end users are customers who want to access their data. For example, banks. Now, if I have a bank account, I should be able to see my account details or bank transactions 24/7 through web or something. So, for all these things, operational systems are required. So, operational systems help these users to access their data. It could be operational data. It is mostly it's operational data. So that's how continuous availability means. Predefined access paths. Access paths are predefined. Now, how do you define an access path for an end user? That is also predefined. How do you define an access path for top management? This is also predefined. Volume of transactions will be very high. Take any operational system. Let it be bank, let it be a financial institution, let it be a insurance company. If you see every day millions of transactions will be happening. So that's what we say. Operational systems will have high volume and data volume per query will be low. This is with respect to your data modeling. Data volume per query. Normally what will happen is when they do a query for a data, the volume will be very low. And it is used by operational staff. Operational staff could be your operational manager, or it could be a clerk in your bank, or it could be a normal manager who wanted to see, HR manager who wanted to see employee availability or information about their employees. So all these things, the operational system will be used by the operational staff. And it supports day-to-day control operations. Every function will have certain functions, like when it comes to finance or HR. When you talk about finance, you have budgets and actuals. Like what is budgets and what are actuals? That will be done by the finance thing. HR, probably they wanted to see what employee information or employee attendance. All these things will be employee attendance, especially is one thing which is operational in nature. Every day employees have to swipe in and swipe out. So all this information will be stored in your OLTP systems. Marketing, yeah, you will have to find out the promotions on a day-to-day basis, on a week-to-week basis, month-to-month basis. Promotions, all these stuff are marketing functions which will be used, like you use your OLTP systems to do this day-to-day operations. And one of the characteristic features of operational systems is large number of users. So number of users who will be using operational system will be very, very huge. Like take an example of bank, you'll have a number of, as I said, banks, they have different types of users. End users, like, the customers, maybe in, millions it will be there, or thousand, in lakhs it will be there. Or if you take bank users or bank functional users, bank employees, all these people who use their operational system. So these are the characteristic features of an operational system. So you just have to have an idea of what is an operational system, like how different is that from a data warehouse. So we'll just see how it differs from data warehouse. Now, goal of information processing. So when you talk about information processing, now whatever data we store, okay, when the data which is not organized, like it doesn't make any sense. So it has to be converted into information. So it has to be converted into information. So data needs to be converted into information. So there is a way in which you do this, because there are so many business questions which needs to be answered. So using data, you won't be able to answer those business questions. So to help the business user to understand to answer these business questions, you are converting your data into information and converting this information into knowledge. That's how we are going to do that. That is what we are going to do in our data warehouse. So as part of your when you talk about OLTP systems, they provide you information system. They provide you information about your operational systems. So like, what is the sales of a particular product for the week. You wanted the answer for this. This is a business question. Let's take the example of Walmart itself. They wanted the operational manager want to know the sales of a particular product for the week. It's an operational, right? It's a day-to-day or a week-to-week question. So this he can get the information from his OLTP system. But if you wanted information like, what will be the sales? What will be the sales for a particular product in the month of December? In the month of December. So this is information like you're trying to find out, what will be the month. So you're trying to predict, like, what might be the sales for the month of December. So this I can make out only if I have enough information. So this is something what we're talking about, knowledge. So converting information into knowledge is what data warehouse is doing. So how do you do that? Let's say suppose we are storing the data for the last 10 years from 2000 to 2015 you're storing the data. So you have got 15 years of data. So based on previous data, you will find out what was the sales in the 2014. You will just find out sales for the 2014. Let's say it's $1 million. So based on that, you will say that in 2015 also you might have more than maybe a 10% increase in that could be there. So you can say like 1.1 million will be your sales for this month. So this is what we are talking about, knowledge. This is what is knowledge is about. Knowledge is something where you derive out of information. So if you see over here, data is getting converted into information using your OLTP systems, and then information, from the information you are trying to derive the knowledge. So that is what the goal of information processing. So then need for a separate information system. What is the need? So we have the data which is nothing but informational data which is distinctly different from operational data in its structure and content. So data, if you have data, it doesn't make any difference, right? It has to be converted into information. So you do a processing. Information processing is distinctly different from operational processing in its characteristic and use of data. Once you process this data into information, you can actually make use of this information. Need for tactical and strategic information. Now, when you say tactical, what do you mean by tactical here? Anybody? Radhika? What do you mean by tactical and what do you mean by strategy? Radhika or Madhuri or Suresh? Anybody?
Yeah, I'm not sure.
Okay, no problem. So when we say tactical, it's again the same, operational or day-to-day. So when you say tactical, it is day-to-day. Strategic is something which is related to the future, like a company is making a strategic decision. That is, a strategic decision is much more to do with the future aspects, which it is much more to do with the decision making. But when you say tactical, it is much to do with the day-to-day. So remember, whenever we talk about OLTP, it is always tactical. You get the tactical information from your OLTP systems, and you get strategic information from your data warehouse system. So over here, we are just trying to understand how what is the need for a tactical system and what is the need for a strategical system. When you say strategic system, I am referring here to the data warehouse. So if you see here, your operational system helps the data. Operational data helps the organization meet operational and tactical requirements for data. So this is the example which I gave. So what is the sales of a particular product for the week? Okay, how many employees? Have attended how many employees have attended for this week? So employee attendance, if you wanted to see for a particular day, all these are operational data. You wanted to see what is the stock left in your godown. So that is also operational data. All these things are operational data which are required on a day-to-day basis. So your operational systems or the OLTP systems will take care of this. Remember, operational systems or OLTP systems are one and the same. So you just use different words. Even tactical systems is the same thing. So we just use different words, but the meaning will be same. And when you talk about data warehouse systems, it helps the organizations meeting the strategic requirements. Now, when you say strategic requirements, we are talking about the future things like forecasting, like what will be the sales for a particular product in the month of December. So this is a future strategic thing, and you are trying to, from a HR perspective, you are trying to what will be the employee retention ratio. So this is a kind of a business question which is strategic in nature. So all these things are, you should try to understand the differences between an OLTP system and a data warehouse system. Any doubts on that? It's clear, right? Operational systems, we are just trying to define operational systems and a data warehouse systems and how they are different. So over here you have an operational diagram depicts like, you have three client systems which are interacting with the operational server or OLTP server and getting the information. And you have a data warehouse wherein you load all the historic information and trying to derive strategic information out of it. That's clear, I guess.
Clear, Rajesh.
Okay. So let's try to find the differences between operational versus analytical systems. Now, since like we have understood like what is operational systems and what is analytical systems, again I'm coining a new word. This new word is nothing but again we are talking from a data warehouse. So analytical systems or strategic system or OLAP system or data warehouse systems, or all these are one and the same. So we'll be using words, different words. Just trying to understand what are the different words. Operational systems, like they are primarily primitive. When you say primarily primitive, like it used to exist to start with. I think when you start storing the data, we started with operational systems. As we have discussed the history of our information systems, we have started with OLTP systems. So they are primarily primitive. And the data, like whenever the data starts created, the data creation starts from OLTP system. So when a transaction happens, it gets stored in your OLTP system. So that is where the data is getting created. The data is getting created. The data is getting created in your OLTP systems. And then primarily derived. So when you talk about primarily derived, so based on this existing data, let's say over here we have got 15 years of data. So this based on this 15 years of data, we are trying to derive information. So that is what we are saying primarily derived. So and in operational systems, the data is much more current. As I said, like in operational systems, you will not store the data for a longer time. So at the most, you might store the data for 1 year. After that, you move the data to your backups. So in your operational systems, remember, your data will not be historical, it will be current. So only the current year's data will be there in your operational systems. Rest of the data will be stored in your backups, or if you have a data warehouse, you put it as part of your data warehouse. And when you talk about analytical systems, yeah, we are saying that it is a historical. That means every year, like whatever data you fetch from your operational systems, you move that operational system data to your historical system. Nothing but the data warehouse. So if you look at the previous picture over here, from your OLTP systems, there is a periodic refresh is happening. That means every day, whatever data you get, you store in your OLTP server, OLTP databases, that information you are pushing it to your data warehouse server. That means every day you are refreshing whatever data which gets added to your OLTP systems, you are moving that to your data warehouse server. That way you are storing the historical information. So analytical systems or data warehouse systems store historical data. And in operational systems, it is constantly updated. So you frequently update your operational systems, but it is less frequently updated in your analytical systems, because data warehouse systems, you don't access it very frequently. Only the top management users will be accessing your data warehouse system. And when it comes to the operational systems, all your operational users, like the employees of the bank or the employees of the Walmart, or there will be huge, right? So it will be frequently used. redundancy will be minimal. And you know what operational system, when you talk about operational systems, any idea of what is a relational database management system? A relational database management system, any idea how it is modeled? So when you talk about a relational database managed system, RDBMS, there you actually do normalization where you're trying to reduce redundancy. So, but when you talk about analytical systems, it's dimensional model. If you look at the way it is modeled, where you actually increase the redundancy. So you are increasing the duplicate. There will be duplicate records in analytical systems. So that's like intended. And when you talk about operational systems, you mainly store the detailed data. So all the data will be detailed when you talk about operational systems. For example, you're doing all the transaction data which gets stored in your operational systems will be detailed, like on a transaction on an hourly basis you store it. But when you talk about the analytical systems, mostly you'll be storing the summarized data. So you'll be storing the summarized data in your analytical systems. Referential integrity, historical integrity. So when we talk about operational systems, how do you develop operational system? Operational systems, analytical systems. So over here you call it as RDBMS, or you say normalization. So how many of you are aware of normalization concepts? Madhuri, are you aware of normalization concepts?
Yes, I'm aware of normalization.
Right. And how about you, Radhika, Suresh?
Yes, Rajesh, I know the normalization.
Okay.
Parent-child integrity constraints.
Right. So when we talk about operational systems, it's all normalized systems. So you create a normalized system, and you use that normalized system to store the data. But when you talk about analytical systems or a data warehouse, this is denormalized. That's what we meant. Over here, you talk about referential integrity. You talk about referential integrity when you talk about normalized systems like operational systems. But when you talk about analytical systems, we talk about historical integrity. So there will be historical integrity between two different records. And when you talk about the operational systems, it supports day-to-day operations. And when you talk about analytical systems, since we are talking about decision making, we are talking about strategic decisions. So it should support long-term decision making. And in operational systems, you use it for day-to-day operations and for business functions. And over here, it is much more to do long-term information requirements. And finally, operational systems, they like you use a normalized design, and over here you use a denormalized design, which is nothing but your star schemas. So what is a data warehouse? Data warehouse, if you start defining it, like the famous definition is a data warehouse is a subject-oriented, integrated, time-varying, non-volatile collection of data, which is primarily used for organized decision making. So now that we have understood what is operational systems, the definition of data warehouse gives a little different, right? Over here, you are storing the data in subject-oriented, integrated, time-varying, and non-volatile. So this is nothing but a data warehouse. So we'll just see how like it works. If you see in the picture, the production databases are nothing but those are the databases where all your OLTP data is being stored. From there, you are moving the data to your staging area, and from staging, you are moving into the data warehouse. So we'll just see how all these subject-oriented. When you say subject-oriented, we are just trying to find out the difference between the operational systems and the data warehouse. So in operational systems, you have something like order entry, billing, accounting, finance, HR. All these are different operational systems. But when you store, this is how you store the data. So when you store the data, when a transaction happens, the transaction gets stored in your order entry, or your billing, or in accounting. So a transaction, the whole thing is stored as a part of a transaction in your operational system. But the way you store the data in data warehouse is quite different, because here you create facts and dimensions, like dimensions like customers, usage, and facts like revenue. So you store as a subject area. Now each of these things are subject areas. Warehouse data is organized by subject area and is populated from many operational systems. So from your order entry, you move all your customer data to your customer subject area. You move all your usage data from your order entry to your usage subject area. And revenue details from your order entry, you're trying to move it to the revenue subject area. That's how it differs. So when you say subject oriented, in your data warehouse, everything is subject oriented. You store the historical information based on subject areas. Integrated. So when you say integrated, what do you mean by integrated? So you have multiple sources. Like, when you talk about OLTP systems, let's take the example of any, insurance company or any finance company or any retail company. They might have n number of applications. Let's say suppose you have 4 different applications as shown in the pictures. Application A, application B, application C, and application D. And each of these application is storing a similar kind of a data, but the way they are structured is quite different. Probably in application A, if you wanted to store the data for male, you're saying M, and for storing the data for female, you're storing it as F. So that's how you're storing the data in your application A. But the same data, when it comes to application B, you are storing it quite differently. There, you are entering 1 for male, 0 for female. And the same data in application C, you are storing quite differently. Like, X, you are storing it as male, Y, you are storing for female. And in application D, you are storing it as, you are writing it as male and for male and female for female. So these are the different ways of storing your data, because these are all different OLTP systems. So they are storing the data quite differently. So you need to integrate all these, data into a uniform standard structure. That is what you are doing as part of your data warehouse. So you integrate all these different kinds of structures into a common uniform standard, and you store it in your data warehouse. Now if you see here, male or female is the standard structure which you are following in data warehouse. So that means you are integrating all the data from different sources, converting that in a common format. Now, common format over here is male or female. So that is what integrated. So the same thing applies for other attributes. Like, if you take, if you see the second example, the pipeline is stored in centimeters. Okay, and in application B it is stored as inches, and in C something else, and in D it's yards. So these are all different ways in which the measurement of attributes are being stored. Now you are converting that into centimeters, standard. So this is how you actually do the integration. So your data is stored in quite different ways, which you need to convert that and then put it in a common way. That is, you are doing an integration. So one of the characteristic features of data warehouse is integration. So you integrate the data from different sources and make it common, standard, and move it to the data warehouse. Next is time variant. So as you know, a data warehouse, it stores a historical information. Now when you talk about operational systems, the data you might store for a year, or you might store for 3 months, or depends on the company to company changes. So when it comes to the data warehouse, you store the data for years. So you have the element of time over here. So it's like if you store let's say 10 years of data you have stored, so you will never change that. So once the data is updated in your data warehouse, it will never be changed. It's a read-only kind of a record. So that's the difference. So in data warehouse, it's like historical. You actually store the historical data, which will never be changed. In your operational systems, you will not store historical records, but you will store only for a certain time, maybe a year, or 3 months or 4 months. It depends on company to company. And data will be frequently updated over here. And non-volatile. So when you talk about non-volatile, you take an example of OLTP systems, you will see all these kind of operations. So these kind of updates. So all these updates will take place. For example, take the bank account. So bank account, or take any example, take the retail marts, or any kind of OLTP system wherein the data gets frequently updated. You might insert a data, you might delete a data, sometimes there will be a request for changing of certain data. So all these are operational requirements where you keep changing your data. But when you talk about data warehouse, these are non-volatile data. Like once the data is stored in the warehouse, we will not change it. So volatility is very, very, very less when it comes to the warehouse. But when it comes to the OLTP systems, it's highly volatile. So you keep changing your data. So that's the difference between OLTP system and a warehouse. So a data warehouse is non-volatile in nature.